A 20-year arithmetic increasing annuity due sells for 600,000, provides annual payments. First payment is X and each payment thereafter is X more than the previous. 25-year arithmetic increasing annuity due provides annual payments. First payment is X and each payment thereafter is X more than the previous. The prices of the two annuities are calculated using continuously compounded annual interest rate of 6%. Calculate the price of the 25-year annuity. So the 25-year annuity is the second one. And we can first focus on the first one, which is the 20-year annuity. And we have for that, the first payment is X, and the common difference is also X because each payment is X larger than the previous one. So we have P is equal to X and Q is equal to X in our typical formula. Now, this annuity is simply X times the unit increasing annuity. So the unit increasing annuity due that we define in lesson 98 basically had P is equal to 1 and Q is equal to 1. And this one, both the ones are being multiplied with X. And so if we recall the present value of a unit increasing annuity due was this one, a double dot 20 bracket minus 20 new 20 over I times 1 plus I, but this is not really a unit increasing annuity. This is an increasing annuity where we have X instead of 1. So the present value will just get multiplied with X. And we are told that the present value is 600,000. So the equation would be 600,000 equals all this. And we are given the continuous compound interest is 0.06. So we know the notation for that is delta. And we also know that the annual effective interest rate is related to the continuous rate through this equation. I is equal to e power delta minus 1. So since we are more comfortable with the annual effective interest rate, so we'll calculate that. So b power 0.06 minus 1 equals 0.06184. Now in this equation, we need a double dot 20, which would be 1 minus 1 plus the interest rate power negative 20 over the interest rate times 1 plus interest rate. Remember, a double dot 20 is the notation for an annuity due, present value of an annuity due, where each payment is 1. And so this comes out to be 12. You can substitute this value in equation 1. So this one gets replaced with 12. And so we have 600,000 equals X times 12 minus 20. And mu would be 1 plus I power negative 1. So it would be 1.06184 to the negative 20 because we have a 20 power here. Here we have the interest rate and then 1 plus the interest rate. So from this equation, X comes out to be 5846.821. Now we have to find the price of the 25-year annuity, and that is also an annuity where the first payment is X and each payment is X more than the previous one. So here also, this is basically X times the unit increasing annuity due. And again, we know the present value would be for if it's just a payment of 1, P is equal to 1 and Q is equal to 1, then we know present value for this one would be a 25 double dot minus 25 new 25 over I. 1 plus I. That's equation 98.7 and less than 98. So if you forgot these, you would less than 98 again. And a double dot 25, like before, would be 1 minus 1 plus I power negative 25 over I times 1 plus I. So that comes out to be 13.34, and then we substitute that over here. And we already know x also. So x is 5846.821, and a double dot 25 is 13.34. So all this comes out to be 779277, and this should be choice D. The slight difference is because of various roundings. So if we look at what choice D is, that's 779336, and we have 779277. So that's very close, less than 100 difference, whereas the others are way apart. So the correct answer is D.